June 2012 Core 4 question 4 is a little bit different to normal. It's just got a formula here. We've got to try and put some numbers in it. We're starting with £1,000. We'll put 1,000 in there. We've got 3%. We'll put the 3 in there. And Mr. Brown's going for 5 years, so we put the 5 in there. So the sum we're actually doing is just 1,000 times by 1.03 to the power of 5. Could have been an old GCSE compound interest question. And it does give 1159.27, but notice it does say give your value to the nearest £10, so do round it that we get 1160. Now, what's going to happen when he first gets over 2,000? So this time we're putting the 2,000 where the V is. 2,000 equals 1,000 times by 1.03, and we want to know how many years n. So divide both sides by 1,000, and we're going to get 2 equals 1.03 to the power of n. So we've got an old Core 1 logs question. Because you've got that button there, you could actually do the log to the base 103 of 2, and that will actually give you the answer you want. What do you raise 1.03 by to get the answer 2? And the answer there gives you 23.45. Round that up, because it says after how many years, you go to 24. Perhaps the more professional way of doing it would be to take natural logs of both sides. Take the ln of that side, it's the ln of 1.03 to the power of n. So the n comes down the front, and divide both sides by the ln of 1.03. Gives you exactly the same answer. So now on to part B. And part B, we're going to be dealing with quite a big log equation now that people did have trouble with the algebra with. Mrs. White, she's got her investment in Bilbao Bank and Bilbao. So we got 1,500 times by this time it's a smaller interest rate, 1.0105, and we want to know how many years it's going to be. That's going to be a T. And now, same, she's going to be, let's find out when it's the same as Mr. Brown's. Mr. Brown's is 1,000 times by 1.03, wasn't it? 1.03 to the power of t. And how do we solve questions when we have the unknowns in the powers? Well, what we do is we take logs of both sides, don't we? We take the ln of all of this, and we write ln on this side as here. Now, how do you take the logs of these things? Well, when you're timesing two numbers together, you can add the logs. So we're going to have the log of this, too many zeros. We'll have the log of this plus the log of this. Now I'm going to save some time. When you do the log of this, again, I've written that wrong, haven't I? When you do the log of this, the t is going to come out to the front. So we're going to get t, the ln of 1.015. This side here, I've got the ln of 1,000 plus, same thing again, bring the t out the front, 1.03. Now it's a case of collecting like terms together and then dividing. So on this side here, I'm going to have the ln of 1,500 minus the ln of 1,000. And on this side over here, I'm going to have t, the ln of 1.03, minus t, the ln of 1.015. Factorize this side here, and very nearly at the end now, work that out and divide it over the other side over there. And so when we get that, we find out that they're actually going to be the same after 26 years. And so they first get bigger the next year after 28 years. A big equation to solve. Here's the answers.